Let's do some Steno coding with Python. We're going to solve the Luhn problem from Exercism, and I'm going to be doing the coding using Plover stenography. Stenography is writing shorthand, which on a computer is done using chorded keystrokes, kind of like playing a piano. You can see how those chords translate into text or computer commands in the Steno tape log below the terminal. Okay, let's get started. But first of all, we'll have a look at the at what the problem is on Exercism, and we'll see what has to be done. Okay, so in our instructions here, we're told, given a number, determine whether or not it is valid per the Luhn formula. The Luhn algorithm is a simple checksum formula used to validate a variety of identification numbers, such as credit card numbers and Canadian social insurance numbers. The task is to check if a given string is valid. Okay, so validating a number. Strings of length 1 or less are not valid. Spaces are allowed in the input, but they should be stripped before checking. All other non-digit characters are disallowed. So some pre-processing we could potentially do there. Now, the first step of the Luhn algorithm is to double every second digit, starting from the right. Okay. If doubling the number results in a number greater than 9, then subtract 9 from the product, then sum all of the digits. And then finally, if the sum is evenly divisible by 10, then the number is valid. Okay, all right, makes sense. Let's go and have a look at what Exercism has provided for us. So we have this test suite here. It has 23 tests in it, and our goal is going to be to create an implementation that makes all of these tests pass in one go. And let's just have a look and see in the tests what kind of code it is expecting from us. So here we go, this part here. So the code looks like it wants an object-oriented solution here, where we'll have a class called Luhn, and it accepts a parameter. So I guess this is going to be the card number, and it wants a public method called valid, which will return a Boolean. Okay. All right. Well, now that we kind of know what the requirements here are, let's move over to the implementation file. You can see just before we begin that all of the tests are currently failing, so we want to make sure that we can get this suite green. All right, let's start. So let's create a class. So the class Luhn. I won't worry about any superclasses here, and in the initialization, we want it to take in a card number. And so rather than just assigning the card number we get provided to self.card number here, what we can do is a bit of that pre-processing using the regex module in order to strip whitespace from this card number. So we're going to say re.sub, and we want this pattern here to be whitespace. So we want all whitespace to go. So we'll say, all right, get rid of white space, and we want to replace it with nothing, so empty string. The string that we want to perform the operation on is that card number, and we're not going to care about any of these other flags here. Okay, so now that we have arbitrarily used the regex library here, let's not forget to import that. So we'll go import re. We don't need an alias for it. Okay, great. So now that we've got our class initialized, let's go and create that first public method there. So that's going to be an instance method, and it's going to be called valid. And it takes in just self, no arguments here. And I'll get rid of the doc string here. All right, so I think that what we can do first of all is we can check and see whether the card number that we have is matches the pattern of 2 or more digits. Otherwise, there's no point in doing any further operations on it because it'll just be invalid. So let's create a guard clause for that. So we'll say, and we can do that with an if statement here, and I can say if not, and I'm going to pretend that I have a private. Let's say a private regex here, and I'm going to say that it says 2 or more digits. 2 or more digits. Okay, and I want to see whether the card number matches that or not. So from here, I'm going to look at self.card number. And I'm not going to care about any of those other further parameters. And if it does not match 2 or more digits, then I'm just going to instantly go and return false. And we'll get rid of that else there. Okay, so that's a good first guard clause. Let's now just go and quickly define what 2 or more digits actually means. So we'll just copy that name. We'll move up here and let's define it. So we'll say that we want to create the regex. We'll create it with re.compile, and the pattern here is going to be a regex, and it is going to be so starting from the beginning of the string, we want them all to be digits. So I'll say okay, digit characters, and needs to be 2 or more. So I'm going to say that there's some repetition that is needed here with at least 2 digits. And we don't have an upper bound here, so we can just kind of get rid of that. And that probably looks okay, I think. So, all right, so that's the guard clause completed. And now let's write the rest of the valid method. We'll write it in kind of like a manifest. So we'll write the code that we wish that we had, and then write the implementation later. So from this self.card number, which is a string, I want to be able to get a set of numbers from it. So, and from there, I want a method that is going to basically give me a set of reverse numbers. We'll make that a private method here. So we'll say that we'll call it reversed numbers. And give it some parens there. And okay, so now that we have been given a new list of reverse numbers from that string there, we want to be able to break that list up into pairs. So I want to say, okay, pairs equals. So Python doesn't have a way to natively do chunking of lists, so we're going to have to do that ourselves. And given that chunking of a list isn't something that necessarily has to do with this object's internal state, let's make it a static method. So I'll say we'll make it a private static method, and we'll call it chunks. And that particular function is going to take in that list of numbers and then the chunk size, which was going to be 2, so that we can basically get back our pairs. Okay, so once we have our pairs, we're going to want a sum of those pairs. So sum of those pairs, and so from there, what we need next is we need some kind of function that will be able to run over every pair to calculate the pairs according to the Luhn algorithm, and then sum them all together. So let's do a combination of the map and sum functions here for that. So first of all, we'll do map, and we'll say, all right, we want to map over the set of pairs, and the function that we want is let's define that one later. But we'll probably also want to make that a static method as well. So we'll say Luhn dot and we'll calculate pair. Not tier, but pair. So yep, that looks okay. So all of the pairs get calculated. So we'll be left with a list of calculated numbers, and then we need to sum them all together. So let's go back here, and we'll use the sum function to do that. Okay, and then finally, what we want to return is whether the sum of pairs is modulo 10 is equal to 0. So that will return us the Boolean that we want. Okay, so that looks like a good manifest to start from. So let's get on to the method implementations. So let's start off with reverse numbers. So that one is going to be an instance method. So that's going to be, where are we here? Reversed numbers. That's going to take in self, no other arguments there. Okay, so what do we want to return here? So we need to take that self.card number. We need to be able to reverse it and then iterate over it and cast every character in that string there into an integer and then return the list of those integers there. And so I reckon that we can probably use a list comprehension to do exactly what we want here. So let's just do that. So the iterable here, in this case, will be not just the card number, but the reversed card number. The reverse card number, so we can use the built-in function reversed, feed that self dot card number, and each of the items in that particular list is going to be a character, so let's just name it char. And what we want to do here is we want to cast them into integers. So we'll use the int function here, and we'll just feed it char. And we don't need a conditional here. So I think that should be enough to give us the list of reversed numbers. So let's now move on to the next function. So this is going to be a static method. And so that's going to be called chunks. Okay, and that's going to take in the numbers, and it's going to also take in the chunk size. So in this case, it's going to be 2 for us. Okay, so chunk size. Right, so what we want to do here is let's create a generator function here that will sort of take a range of numbers, it'll iterate over them, and then it will yield up a slice of the numbers list of size, chunk size, to the caller. So I think that we can probably do that using a for loop, and the iterable in this case is going to be a new range. It's going to start at 0 and stop at the length of the chunk size. Not the length of the chunk size, but the length of the numbers. And the step is going to be of size, chunk size. Okay, and that element there, we're going to basically be getting an index out of that particular range here. So we're yielding up a slice of numbers based on the indexes. So from here we want to yield up from numbers a slice. So let's do that, and that slice will start from the index. It will stop at the index. Index plus the chunk size, and we're not going to worry about the step here, and we're not going to worry about else here, and that should probably do it, I think, for chunks. Okay, so 2 methods down, 1 more to go, and it's the most important one to calculate the pair. So this is also going to be a static method, and we're going to call it calculate pair. and that is going to take in a, oh, how'd that happen? Take in a pair. Right. Okay, great. So from here, given that the card number, when we receive it, could potentially be an odd number of characters or an odd number of numbers, when we chunk out the card number into chunks of 2, we might end up in the situation where the odd number out there is given to us in a chunk of 1. So this pair here may not actually be a proper pair, it may just be a list of 1 value in here. And in that case, we don't have to do anything with it, we just need to return it back. So let's do that via a guard clause. If, and we'll say if the length of the pair equals 1, we just return the pair and the first element of that pair. We can get rid of the else clause there. So that should be okay for the guard clause there to make sure that we actually have 2 elements of this list. So now that we've confirmed that we do have 2 elements, let's destructure out this pair here. So we'll say first and second equals the pair, and what we'll do here is we'll say, okay, what's the first calculation we need to do? We need to multiply the second value. So we need to multiply it by 2, right? So multiply by 2, first thing. And then we need to do another operation on the second value. And that is where if the second value is more than 9, we need to subtract 9 from that value. Otherwise, leave it as it is. So we can do that using a conditional. So the condition in our case is the second is more than 9. If that is the case, then we do second minus 9. Otherwise, we just give it back the second value. And then finally, what we need to do is return the first value plus the second value. And I think that is probably going to be it. Let's go and check the tests. Yep, and so the test suite is now passing, and PyCode style also seems to be happy with it. So the robots are happy with the solution as well. So I think we did pretty good. And so that is the Luhn problem in Python completed with Steno. Thanks very much.